everybody. It was really well received. And Jim's going to give you an idea of what the research behind the information that he's going to present, how they came up with it, and the whole thesis, if you will. So basically the title is How Studies of Crane Accidents and Trends Lead to a Safer Work Environment. We also have Mike Parnell, president of ITI, here on the line as well, and he'll be helping out with a Q&A session at the end. And just to give you a little bit of background, if you're not familiar with ITI, we host this webinar series once a month. We're really a crane and rigging training and consultant leader around the really Western Hemisphere. We're big in the U.S. and Canada, do a lot of work in South America, and we're expanding across the Eastern Hemisphere as well. So serving a variety of industries, and Jim will probably touch on accidents in a bevy of industries like a lot of you are a part of. And missed a slide there, but we have a lot of folks on this call actually from, I noticed, from Kiewit and Exelon and PCL. We serve a lot of the world's greatest companies like those I just mentioned, and we appreciate your support on this call. So a couple housekeeping items. The webinar series, we have several past presentations on the website, so you can actually access these just at the iti.com/showcase. You can download the presentation. You can view the past recording. Today's presentation will also be available on there. We're recording it currently, and the presentation file which we're looking at will also be available. So I really want to say thank you to Jim and Haag Engineering for providing this presentation and making it available for us all to view later on. So the last thing before I get into the bios, and housekeeping item, if you all have any questions, there's a chat box or a question box in the control panel, and we'll be basically taking questions throughout the presentation and having a QA session at the end. So into the bios, what's really neat is both Mike and Jim are industry experts. They're both a part of the ASME B30 main committee, so it's pretty neat to have both of them on the call at the same time. Mike is the vice chairman of the B30 committee, and he's actually the chair of the ASME P30 committee, which is a new rollout this year, in 2013, which is going to be setting standards for lift planning. And getting into Jim's bio, he's a professional engineer, and he's basically completed over 700 crane accidents. When I read this the first time, I called up Cheryl, who's basically works with Jim, making sure that was a accurate number. I was just shocked how many investigations he's been able to do. And like I mentioned, he also serves on ASME and quite a few task force, including NCCCO, task force for rigger and tower crane. And he has a University of Texas educational background and Baylor University. So you'll see his you'll see the engineering background in this presentation as well as the computer science, actually. And what I'll do, Jim, I'll just pass over to you right now, and we'll be viewing your screen, and just take it away.
Do we have it? Are we all on?
Yes, sir. We got it.
All right. Well, I appreciate the opportunity. My name is Jim Wiethorn. Just a quick background, third-generation general contractor. I grew up in the construction business, owned and operated cranes all my life, and basically they've intrigued me since I've been very young. I hate to admit, I started operating when I was 14 years old. And when I almost tipped one over in the yard one summer, I decided I better read the manual. And so it has often been a very interesting item for me to look at. And once I joined into the forensic field, it became an obvious task to head in that direction, to work out in the field, find out what problems are occurring, and try to assist on to preventing them from happening again. Once I got into probably around 300 crane accidents, we're now at 744 as of this year. We average about, over the last 10 years, right at between 90 and 100. I just got back from New York on the one that flipped over Hurricane Sandy, and also working on the one in Australia that just caught fire and collapsed. So work both nationally and internationally. But I wanted to take this information and try to see what kind of information I can get to be better able to serve both on the committees and to help my clients, because we're doing quite a bit of crane safety program evaluations now. We just completed our 4th one, and Mosaic Mining, Thies and Krupp are some of the most recent ones, and trying to evaluate what they're doing. Are they following industry standards? Are there any shortcomings in some of their programs? But in order to put a study together, I kind of listed out some of the things that I had to gather together, and I began this about 2006 and had the first round of the information put together and presented in 2008. And so one of the major issues I had to get after I decided I was going to do it was to know some basic parameters. What am I really trying to look for? And my key issue has long been duties and responsibilities. In my profession, probably one of the #1 things that I'm asked to do was what caused the crane accident and who was responsible. To have that, you've got to have some kind of guidelines. And so fortunately now we have the 2007 version of ASME B30.5 and many of the other subcommittees that give you some guidance there. But what I did was take the 2007 version and went back to my first crane accident, which was in the late 80s, and apply it uniformly just to see, are we improving? Are we improving with our crane operators? Are we having less issues there? Are we still having continuous problematic issues with critical lifts? Things of that nature that I wanted to be able to test. So by doing that, I'm going to be able to look at a trend on what we're looking at. Although those standards may not have been in existence, or they were in the clients were there, industry standards were there, but the standards were not in place. And then once I got to that point, I needed an assistance from some type of recognized peer review group or institution that would authenticate the data. And so I could go out, make sure that what I'm doing, the statistics that I'm putting together, weighted averaging, things of that nature would be valid and agreeable in the industry. And then finally, you had to have an adequate data bank, which obviously we have had. First thing I did was went back and traced where did the duties and responsibilities really come from. And back in the early 60s, if you look at the International Association of Bridge and Structural and Ornamental Iron Workers, they go into quite a bit of detail as to the duties of each participant in a lift. At that point in time, they had the crane operator, they had riggers, and they had the person directing the lift. And so with that, then in the 70s, Don Dickey published 3 books which anyone that's been in the crane industry knows or familiar with. And if you look at his diagrams, and so forth, those are from the Union Ironworkers Manual. And he took that and developed that into more of a refined list, including site supervision, lift director, renaming the person directing the lift to lift director. And that went through and was still involved through 1988. And back in the 80s, I had attended several of his presentations and became even more intrigued. In 1989, there was a crane accident in San Francisco and resulted, I think it was 4 deaths, 20-some-odd injuries. And at that particular point, when going through and analyzing it, so often the response was, well, that's not my job, which you hear quite often. So it became apparent something had to be done to identify what your job was and what you're supposed to do. American Society of Civil Engineers put together a task force committee that developed and ultimately published officially in 1988 this ASCE manual and reports on in practice number 93, crane safety on construction sites. I taught a 2.5-day course at the University of Wisconsin on this manual from 1998 till about 2004, at which time it became apparent that ASME, which your standards are always the last ones to come into line because they're letting things play out, they're letting what works, what doesn't work. And after quite a number of years of battling and discussion amongst the various parties, in particular 30.5, the ASME 30.5 2007 came out with the official duties and responsibilities of parties involved in lift. So that's kind of the history as it came about. This drawing a sketch from the ASCE manual, and it graphically shows you in very simple terms who's responsible for what. The purple is either the crane owner or the service provider. A service provider is the normal crane company that's going to lease you a crane, and it goes into a list and duties of what they're supposed to do about having the crane certified, the maintenance issues, etc. Then you have the crane operator. His responsibility starts at the bowl of the hook and goes and includes the entire crane down to the outriggers. Then we have the rigging function, which goes from the hook, including the load, and they assist the operator in placement of mats and visually watching the mats during operations to ensure that you don't have some type of subsidence that could lead to an incident. And then finally, you have management and lift director. The lift director is in charge of everyone. That is the person that selects the riggers, discusses with the operator what's going on, and actually puts the lift together. And in most instances, will be there at time of the lift. On critical lifts, he is responsible for being there at all times. Excuse me. If we go into a flow chart, we have, your lift director is the primary party. There is a site supervision in the new ASME, or really that's ASCE, and that's dealing more with preparation of the site, making sure hazards are out of the way, craneway is in good shape, things of that nature. The lift director will check to make sure those things are done before he begins the lift and has everyone set together. And then under the lift director, you have the crane operator and rigger. Now, often the signal person is also a rigger, but you can't have an independent signal person. And then the lift director will be dealing directly with the crane owner, which may be himself, the user, which may be a subcontractor, or the service provider who just provided the crane or crane and operator. So that's how the responsibilities flow down through and who's responsible for what. In developing my issues, being on numerous committees, I polled and discussed with what's often referred to as subject matter experts. Went through what are the problems you're having, what are the questions you'd like answered, and with that I was able to develop a very comprehensive list of items that we evaluate on every single accident. And with the recent publication of our study in June of this year, we have significantly increased that and are even more sophisticated now. Originally what we did was divide it into 4 different groups because you definitely have different types of uses of cranes, you have different types of certifications and qualifications. Commercial construction, you'll have multiple users on a site. Almost the exclusive use of tower cranes is in the commercial area, although you can have it in others, such as in some highways and bridge. Consistent lifting with different loads and radii, and loads are often made in tight quarters, and you have multiple workers working close to that the load itself. Highway, road, and bridge, a lot of the work is done at night. It's probably the most often used critical lift because you're using 2 cranes. You're often traveling with loads. You have unprepared craneways. You can be out in the middle of nowhere, so it's difficult to make a craneway at every one of the vents where you're setting different types of loads. It's very tight and complicated lifts that you run into. So it's a considerable different industry than commercial. Industrial manufacturing has their own problems in that consistently what I run into is what they refer to as certified operators. I will give you an example. I was looking at an accident in Louisiana, and I asked who were certified, and they gave me a list of 64 operators for one crane. And basically the bottom line was the first one that got to work got to run the crane that day. And so you're running into different people use a crane different ways, and misuse is a big issue there. They're running 24/7. Maintenance is often a problem because they don't want to take it out of service. Under normal design parameters with the larger companies, you will have 2 cranes in each bay so that you can have one down for maintenance while you're using the other crane, but that's expensive, so very few do that. But normally you have consistent identical lifts. You're moving product from one point to another, and there are numerous adjustments are made that are industry specific, and they will take exception on a lot of the items where they are working. And in particular, night shift seems to be our worst problem when we trace them back to when they were done, whether they were done early morning hours or during the day. You have less supervision. Production is a big issue to show big numbers for the next day. Residential, problem there we run into is no qualified riggers. You bring out a crane to a residential site. Normally they're just carpenters. They have no idea what a crane is, and probably the most common is setting roof joists. They're unfamiliar with rigging, so we have a lot of problems with the bundles of trusses being set, and they try to set them down and then they can't control them. And too often then the operator is brought into the lift to try to help them rig it, and then he becomes held to a higher standard. Because one of the issues with ASME is the operator is one job. His job is to move that load from point A to point B, and not responsible for making sure all the rigging is correct. Although if anything that he sees that is out of the ordinary, he as well as anyone else has a duty to get involved. From a peer review process, I wanted to establish a working relationship with either a recognized organization or a university. One of my interns that had worked with us for 4 years, I made him a job offer, but he had his master's degree, and I wanted him to do it on a portion of our accidents so that we could get, number one, some real good software developed just for our use, things that would allow us to better evaluate data. I know guidelines for acceptance level of data. I may have 440 crane accidents, but if the information I have does not achieve a certain level, that is, there's 2 sides to every story, then we don't include it in our study. We will include it in from a type of accident. The crane tipped over, we had rigging failure, but from an analysis of who is responsible, we will exclude it from that. So we use them to initiate our study, and what they've done, they came back and suggested that we include marine use and as a 4th category. And so now we have, that should 5th category because we already have 4. So it'd be marine use, and that would be on, of course, any kind of port authorities, dock facilities, things of that nature. Our data bank, back in April or May, we had about 694 crane accidents. As I said, we're right around 740, 774, somewhere in that area. We have worked in every state except South Dakota. And so I'll do a job in South Dakota real cheap if I can get one up there to have a complete covering of the entire United States. We're working internationally. I've worked in Africa, Brazil, Canada, Puerto Rico, Sky Coast, Virgin Islands, and of course at that time I had not done one in Australia. We're working on that one now. And then on the left is the different types of crane types that we have laid out. And if you see the mega crane, that's basically dealing with anything over 1,000 tons. That can be anything from a transit lift to, of course, the newer cranes that we're running into are very large and can have significant capacity. You will be surprised what we get, the homemade cranes that people try to do, and so we have a category just for those types of cranes as well. When I had Ray speak out and say he wants to do his math and he wants to use our study, we have significant contacts throughout the United States. He applied to, I think, 10 different universities. He got immediate response, and the one that wanted it the most was MIT. And so Ray went to MIT, and he graduated in 1 year, and we published the first, we had just 90 crane accidents in that particular study. And they are working with us now on our current study. And so we had the first publication that came out, and it dealt with, as I said, around 94 of the crane accidents. If I look at some of the data between 87 and 2008, we had 378 crane accidents that we could physically look at that we had sufficient data at the criteria that MIT had established for us. Out of those, we had 317 that were categorized, commercial construction, 124 accidents, highway, 33, residential, 20, and industrial and refining, manufacturing, 140. We also separated out critical lifts, and we had divided the critical lifts as either multi-crane lifts or they were specifically laid out as a critical lift, and they had a lift plan that was specific for that procedure. And the different crane types, our number one crane accidents that we have are mobile, which is not mobile hydraulic, which is not unusual because that's probably more mobile hydraulic cranes out there than anything else. Mobile lattice were number 2, which once again would not be a surprise. Tower cranes were 3, and bridge or overhead cranes were 4. So those were the 3 types of, or 4 types of major types of cranes that were involved in the accidents that we looked at. From a responsibility standpoint, operator still was number one cause of accidents at 25.7% of our accidents. Our riggers were number 2, lift director, and then the site supervisor. Now, what is interesting in this is what we found is that from a failure mode standpoint, rigging was by far the number 1 cause of accidents. And when we are currently also including a number of injuries, deaths, property damage, etc., and rigging is by far one of the major issues that we have found to be problematic with cranes. And number 2 were mechanical problems, and that's everything from lack of maintenance and some isolated instances of around 5% is design issues with the crane. And then we will go to crane stability, and then just the physical attachment of the load. In some way it became detached from the load itself. From a critical lift standpoint, changes in the plan led the way as our major cause. And invariably you have an accident that you have the plan all laid out, everything works fine, you get to a certain point, and something isn't like it was supposed to be. So they make changes right then on the site and continue. Rather than stopping and evaluating the consequences, they go ahead and make that change, and almost 40% of the time it ends up in an accident. Number two were site controls. Now, site controls are normally dealing with traveling with a load. We had a DVD for the Texas Department of Transportation because of the number of accidents on road and bridge and highways, and where we define critical lifts and we get controls on where they would, what percentage of the allowable load they will be able to use, and site controls was one of our issues. In other words, you need to have the travel path laid out. Hopefully it's a straight line. You have a surveyed line. Number two, you have control stations. So as each crane travels, when they come up to control station, both of them are traveling at the same rate and parallel to each other. Because too often we have a situation one crane gets ahead of the other, or one crane starts to, as they're traveling, get further and further away and pulls the other one over. Rigging, and then believe it or not, wrong weight with brings up the rear operator was number 3 as far as critical lifts are concerned. And so how do we want to use this study to improve safety? Those topics in each industry are which are most problematic. That's what we're going to identify. And I still remember Don Nick one seminar where he brought up the issue, if we could just get people before they did a lift to make sure that all the outriggers were extended, just do that simple task, they reduce, like, I think it was 50-some-odd% of the accidents that were occurring in Canada. And so that's what we want to start doing, is bring those issues up, bringing those to the committee so that they, does it have enough credence so that we need to include it in the standard and to better have a safer environment out at the job site. We want to implement internal lift planning and operational procedures. One of the things that we do numerous training sessions for major contractors. We just finished another one for Austin Industries this year. They brought in 600 of their superintendents from around the world in for a day and a half or 2 days seminars. And one of the things that we bring up is the use of a written lift plan. And we don't want to burden you. What we want to do is give them the idea that what it is a checklist. You go down that list, have I looked at this? Have I looked at that? And you check it off so you don't inadvertently forget to check something. And it's something that doesn't take long. It can be done quick, just on conventional lifts. Obviously, with critical lifts and more severe lifts, you're going to go into much more detail. And identify corresponding areas of certification or training trends. We're going to be looking at, are we getting better with operas? Now that we have certifications for crane operators been in the longest, are we seeing a trend of less and less per year accidents caused by operator error? Similarly, now with rigging coming into play and with signal person, and I know the lift director will be coming out shortly, we'll be able to track trends to see, is it working? Are things working? Are we getting better and safer at things as we continue along? Because one of our biggest issues that we're running into is change. Cranes with the electronics, with the advances in metals, in analysis, cranes are getting leaner. The margin of error is getting smaller. And even if training is trying to keep up with that steady growth in technology, it's hard to do. And so it's going to take a concerted effort on a lot of people to make sure that that does serve its purpose and serve it well. If we look at crane types, the overall comparison, crane types by industry, this is just the different types of crane accidents and crane types that we have in the commercial, industrial, highway, and residential, just to see, so you can see exactly where they are petitioned out. As I said, the study does break out each one of those industries. So you can look at cranes overall, or you can look at cranes just in the industrial and refining market, commercial, highway, or residential. One of the things that was really interesting, and I had I forget who it was, one of my colleagues mentioned, I wonder how many crane accidents occur with no load on the hook. So every single one that we look at, we look to see did the accident occur, was there a load on the hook when the accident occurred? And if you look at the highway, road and bridge, almost 50% of the accidents occurred with no load on the hook. And that's a startling number to me. And also, just overall, almost 32% of the accidents overall in the industry was no load on the hook. Some of the other issues from a commercial standpoint, riggers lead the way as being contributory to accidents, lead the way there, along with the operator in that commercial in the commercial industry. Industrial operator 40%, and also in the residential area, which, as I said, indicated earlier, you have the least amount of experience per se just in lifts and cranes. The lift director and the rigger are by far one of the leading causes. If we look at overall comparisons on some of the other issues, if we look at Powerline Contact at the bottom, highway, road, and bridge leads the way. And I'll tell you that 90% of these are dealing primarily with moving construction barriers, the CTBs, the concrete traffic barriers, or K-rails, or Jersey barriers. Invariably, they're being done at night. They're being done rapidly. And even though you may have aware of power lines, you get busy, you forget about it, and the average number of deaths is almost 3 per power line contact, because you end up with someone on the ground usually gets killed first, and someone else comes in to help him, and then a third one, and then so it ends up being very, very, very tragic. Boom impact, too. You're in close quarters, moving and rotating booms very close to concrete vents that are up in the air, and with any type of deflection or rift, you contact a member, one of the fixed members, such as a concrete vent, and it will buckle the boom. In the commercial construction, signals was a pretty strong area. And then residential, I won't get into that much because we probably don't have many people in that, but it's pretty well wrong weight, rigging, and just not knowing how much it weighs are consistent a big problem. If we kind of summarize it, in the commercial industry, the highest occurrence of accidents were associated with rigging, followed by external engineering design and improper signals. Now, when I say engineering design, I guess beginning with the tower crane failure at Bellevue, there are a number of cases, particularly with tower cranes, where we have the engineer of record on a project truly doesn't understand how to convert the loads that are provided from the manufacturer to be applied to the building. And as a result, we have a fairly dramatic and sudden occurrence. And if I talk about engineering issues, weight stability calculations, demolition is the leader there. Invariably, probably the #1 cause as they're dismantling bridges in particular, they'll take long undergirders down that are just unstable. And most of the time they don't even get them picked up. They just are tied on them, and they just roll over, and you have lateral torsional buckling, and it pulls the cranes over. So we have a fairly significant challenge from a demolition standpoint to have the engineers go a little bit further and understand the weight just isn't the issue. Can the load and will the load be stable while it's being picked and lowered? Special applications where you have field changes. You need them done quick. Invariably, mistakes are made. Design changes. Either you refurbish or you have, other than original equipment manufacturer, items that are put onto a crane, tire crane base design, tie-in, and shop-built cranes. All of these are issues that we run into on a fairly regular basis. From an industrial, and industrial is refining as well, elevated number of accidents associated with operator error. Here, no matter if it's a refinery or an industrial park, you have multiple operators that are running cranes, and the train and the experience just isn't there as it is on a conventional crane on conventional construction such as commercial. You have people that are working odd hours, not as much supervision, so they start to get lax, and you start to run into problems there. They're just trying to get around it. Not that they want to do anything wrong, but production is a big key to them, and so they will try to take a shortcut. Highway, road, and bridge. Almost 50% of the accidents occurred with no load on the hook. Majority of the no-load accidents were associated with crane movement with poor or substandard preparation. Secondary issues were movements on the site associated with Powerline Contact. And the third factor was assembly and disassembly. Still my leader on accidents with, and obviously almost the majority with lattice booms are in the highway, road, and bridge division. Significant number of complex and critical lifts correspond to the highest percentage of site supervisor responsibilities. On a lot of the projects, you'll have multiple crews working. You'll have one site supervisor trying to prepare the site, make sure that they have compacted material or they have a level site. Within the city, you will have issues where they're continuously having to run over curbs, having to obstructions that make it difficult and make the lift even more complex. And we have the highest number of accidents with the boom striking, stationary ships, and collapsing, because once again, you are working in a very tight field, and even the slightest move is difficult. And remember, a lot of these accidents or lifts occur at night when the traffic is the least amount, and so lighting becomes an issue. Its depth perception is a problem. Residential is just lack of lift planning experience. Resulted in elevated accidents associated with lift director and the rigging. They really don't understand cranes. Instability of the load after being lifted. Then that is confirmed with the issues with rigging. They rig it up, but then they don't. It becomes uncontrollable. It starts to move. It strikes in workers. And then finally, unknown weights or wrong weights, similarly with associated with rigging. So rigging in residential is a large issue. As far as our future work, our preliminary study, Haag MIT, was issued in June of the year, and it covered approximately 100. It was 94 to be exact. We did have procedures that were established by MIT. Those are going to be implemented into our first comprehensive study, which we should have about 680 is our best count right now that will be able to classify. Although we have well over 700, we're going to be eliminating some of those because we don't meet standard of sufficient information to end up with a cause from a duty and responsibility standpoint. That will be issued in March of this coming year. We're well on our way and have all of them inputted already, and we're ready to give percentages of types of accidents, which we're going to use 10 different types of accidents, and that will be industry-wide on all uses of cranes. We can break that down into each one of the separate categories. And it is our intention that we'll be updating and issuing an update on the crane study every year. Several issues will be brought up. One of the things that I mentioned a little bit earlier, I'm doing a separate article, and I'm addressing it also with this one up in New York, where trying to give some guidelines on tower cranes. And the chairman of the Point 3 committee, which is tower cranes, Peter Juran, he and I have discussed what I'm going to be writing up, and we have done finite element analysis of numerous tower cranes. We're looked at what is the average or the maximum wind speed that would cause physical failure or elastic deformation of a crane. Most of them at their maximum height above a support is around 124, 125 miles an hour. And just by taking out one section, we can bump it up to 140. In two sections, we can bring it up even higher than that. So one of the issues we're going to be talking about is planning. Planning crane use, tower use in hurricane-prone areas, and how to have your maximum unsupported height during the spring and early summer, and then beginning about August, November, to have no more, have your maximum height reduced by at least two sections, tower crane sections at that time. So that's going to be one of the major issues that we'll be discussing. We are reformatting. Also, we're going to be doing it by specific year of occurrence. Most of the way the study was done originally was, when did I receive them? In some instances, a crane accident may be 2 years old when I get it, and so instead of putting it in the year I got the accident or was assigned me, what I'm doing is putting it back into the year of occurrence. With that, we've realized we've gone back to 1986 or 85 now with the number of crane accidents that were originally it was 87. Trips will be examined to study the effectiveness of training and certification. We'll be in a crane operator certification, signal person, and rigger. Obviously, crane operator is going to be is the one that's been in existence the longest, so it will have the most precise data. It will be more effective than signal person and rigger. Signal person will be next, and rigger will be third relative to looking at trends. Is it working? Ultimately, the lift director certification currently under development will be evaluated on an annual basis, and we're going to be submitting some of these problematic issues to both OSHA and to ASME for consideration in future standards. We think with the physical data, I've been in contact with the Solicitor General, and they're very interested in participating, and so we will be supplementing them as well on an annual basis. So that is my presentation, and if Mike, if you have any input or if any questions that you have now, I'd be more than happy to answer.
All right, Jim, thanks. Great job, and I'd like to see if there are any questions. Zach may have been accumulating some of those questions during your presentation, Jim, or before. So let's just see if today's session has generated anything, and see if anything is pondered out there, and with all of our friends online with us. Zach, do you have anything accumulated?
One question came in. I do want to let everyone know, again, you can insert your questions on the right with the module. Basically there's a little orange arrow up there. You can insert questions. But basically this question was a pre-conference one. I'm going to open up that document again too, and trying to understand the future. It sounds like this person had attended the CRC workshop, but was trying to understand if the future work that was going to be happening with the crane study and whatnot. So I think you touched on that, Jim. Do you have anything else? Were those slides pretty recently updated?
No, it's the same ones.
Okay.
I won't update the release of the study in March will be the complete first round in study.
Okay. Jim, I have a question in relationship to that. You had a segment right up at the beginning about marine or maritime. Will that be a new category under consideration?
Yes, it will. We have a lot of ship accidents and at ports and so forth, and so we're going to be that will be a complete separate category.
Okay, very good. Okay, Zach, any others?
I'm going to dive into more of the pre-conference one. They basically, gentlemen asked how they get a copy of the complete study. Is that possible, Jim, or is the presentation all that is given out?
The complete study will be available in March, and
okay.
I guess you could get a copy from MIT of the preliminary study, but our study will be available in March of this year, hopefully by March 1, because we're well on our way and we're in good shape right now and I think you're going to find a lot of valuable information in there, and because we will be addressing each industry and areas where we feel that are either problematic, concerns, areas where we believe there should be improvements.
Okay. Terrific. Well, a couple of questions recently, or just came in actually. Richard Cravendam asked, when you talk about accidents caused by stability issues, did you mean that the outrigger pushed to the underground and that not enough load spread mats were used, or were there other issues?
It's all of the above. Stability means that in our study that the crane overturned. And that's why we're trying to make the top 10 list very simple and categorize them. Then get into subsets where we talk about what caused it. For instance, in one of my presentations, I show a very common practice of where you have an RT out on a construction site, you're pouring columns, you're moving the little RT around, and halfway through pouring a column, the outrigger plunges through an old excavation that had been rolled over and was nice and smooth, and it dropped about 8 inches and the crane tipped. That's still stability, that's still overturning, but the cause is going to be improper or failure of the underlying soil. You could have mats, you could have slope stability where the ground underneath it's caved off, but still the number one, the primary issue is going to be it returned.
Sure. Okay.
And obviously overloading, I mean, there's a lot of different things that you can have that are going to be associated with stability. That will be explained. Each one of these, of the items are explained in detail on what we have an entire 5 or 6 pages of explanation of what the categories represent so that you can
Sure.
follow it. You don't have to try to guess what I'm saying.
Sure. Okay. And another question seemed to come in on a definition of the report, and I'm sure they can find it on the report, but if there's a short answer to it, Bruce asked, what was the report's official definition of a critical lift?
Well, right now, as you probably know, there is no definition. The only thing that is official anywhere is multiple cranes. Now, what we've done in the DVD that we produced for Texas Department of Transportation, we went through all the different possibilities of identifying the critical lift. Mostly what you find from OSHA, they are going to rely on the company that's using the crane to define their own critical lift. Some say 50,000 pounds, and some say types of rigging. I mean, that's an internal issue, but we do give that guidance, and yes, we do have that. I think it's on our website where you can get a copy of that DVD, which goes into a lot of details, and then also gives some parameters how to establish guidelines for percent capacity of your allowable based on what you're doing in the field, like control limits, etc.
Sure. Thank you. Another question came in regarding, well, basically any investigations or studies that show the daily amount of working hours that might have influenced. Do you have that sort of data, or can that data be found in the report?
No, it isn't right now. I will tell you, I've seen a very interesting, from the standpoint of injuries, which we may be doing this. It just depends on how far back I can. That on most injuries that we have, and ones that are serious, workers are at the site less than a week. So it's new people that come out to the site, aren't familiar with what's going on. They're put into the middle of a situation, and out of that percentage, a large number are the first day out on the site. So I guess my recommendation is when you're bringing in new people, work them into it. Don't throw them into the middle of the fire, because that seems to be an alarming trend that people that get injured or don't understand what's going on usually are working less than a week when they get injured.
Sure. Yeah, a lot of these questions seem to be about how Haag defined a lot of the parameters. I'm sure if you guys
and that will be in the at the very beginning, and it will go in detail. It's very detailed as to how we defined each one of the items.
Yeah. Good. Let's see. Are there any indications that time pressure may have some influence within the highway or construction industry? Or the highway, I'm sorry, that's spelled out funny, but the highway construction industry.
The only, I would say it probably does. Can I document it? No, because invariably you normally have a very small window. You can only shut this road down in certain times, and you got to have it done by a certain time. So that leads then tends to head toward the issue once again about have changes in your critical lift plan, but you got to get it done. So you go ahead and make changes and continue rather than stopping and wait until the next night.
Mm-hmm. Okay. Well, thank you for that. I think a couple more questions coming in here. I'm trying to sift through them. They come in like hotcakes. Let me. Do you have any information on crane safety regarding utilities and lift stations?
I've had several accidents at lift stations, and that's going to be in the commercial industry. I don't separate it out from the commercial construction.
Sure. I think for the viewers, just for everyone to understand, Jim, it was probably a big setup of this whole report was how to define how granular you guys were going to get, right, with the different parameters and the different elements you're going to define for each accident. Is that right?
That's correct. And that, as I said, was a big help from MIT that helped us, number one, classify the accidents where we can do a complete analysis, or we just stop and leave it just as a type of accident. And sure. And so that's been a great deal of benefit to us. And as I said, everything that we're doing, once you read the first 5 or 6 pages, then you can, and I guess, hold on to them, and because as you go through until you understand all of the how we've defined things, it's not hard, but you want to know what we're thinking as compared to what your thought of a particular definition is. And so that's why we've gone into taking great pains to make sure we explain each type of issue, down to manufacturing defect, which 5.6% of our accidents were manufacturing defect related. In 2008, that number jumped to 16%. And of those, 90% of that was associated with either copied rigging equipment, copied cranes, forgeries, basically. And also quite a number of them with Chinese type manufacturers, where we were running into issues that they were, and let me give you an example. An anti-2 block on a tower crane and the use of the speed controls where you have ramp up and ramp down. Obviously with a tower crane, you pull the lever, it starts off slow, increases speed, goes fast when you're in high gear, and then the same thing when you get to the top, it automatically starts to shut it down at a certain point, and it slows down and then comes to a stop. Then we have the ATV. Well, in 2 of the accidents we looked at that were Chinese manufacturers of tower cranes, we had 2 block instances where the block in the bucket fell because the two didn't communicate. It got up to the point that it was supposed to shut off for 2 blocking, but it was going so fast it had to ramp down, and as a result, it went right through the 2 block stop device, and 2 block and it failed. So in some instances, it's issues that, I guess the best way to say it, if you've ever read a foreign manufacturer's manual, their means of English and ours is sometimes doesn't mean the same. And I know, like Tadano, I've rewritten 2 of their manuals to put it into better what the U.S. version or our understanding of what they're trying to say is really occurring.
Interesting. Well, it sounds like they're, I mean, and just from my perspective, were those cranes or those accidents in the U.S. or in the Western Hemisphere, or where were they?
U.S.
No kidding. Wow.
Yep.
Interesting. Well, another question came in, Jim. It looks like this might be one of the last ones. Are you finding that operational aids are becoming more of a necessity to safe operation of the more sophisticated computer-controlled machines?
Well, it's kind of damned if you do and damned if you don't. I have a real problem, for instance, with the new OSHA standard that allows an operator to pick up a load if he doesn't know how much it weighs, and he picked up, and he's allowed to apply a load up to 75% of his chart to see if he can pick it up. Well, and you know, my rule has always been, if you don't know how much it weighs, you do not pick that thing up until you find out what it is. But this is, I think, is just opening the door for operators to start doing that. Small lack of attention, and before you know it, you overload the boom, and the boom comes crashing down. It still, we're running into people not using operational aids like I believe they could. They are aids. And like the standard says, they do not replace your judgment, good judgment, and common sense. And you need to approach these lifts just like you were taught, and not keep relying on all the operational aids. They're great tools, but that's what they are, is tools. They're not doing the work for you.
Good point. Very good point. Well, let me, I'll wrap us up here with 2 thoughts from our attendees. And the first one, just a clarification, are crane accidents that occurred in connection to land rigs, oil and gas rigs, which area are they under, Jim?
I'm sorry, I didn't hear that.
Which area, like, are crane accidents related to upstream operations, I guess, oil and gas rigs? Which area of the report are they under?
I am now going to have a separate division for drilling rigs, because that's another. We've actually added. We're going to have a total of 8 categories now, and one is going to be rigs, because we have so many drilling rig accidents that we're going to set it off into a separate entity. And that was one of, once again, the MIT told us, you know, once you get through it and you see a category of a certain number in a field, don't try to lump it into a large field, separate it out. Don't go crazy with it. And so drilling rigs are going to be one of the separate items that we have as well. It's crane accidents.
And Jim, this is Mike. Maybe are they currently likely listed under the commercial category? Would that like an oil, like a gas refinery, oil and gas refinery, or drilling operations might be either construction or commercial?
If I recall correctly, I'm sorry, I don't know this exactly. I think we put that industrial and refining as part of the that all into one industry. And that was another thing. It wasn't. We were finding more and more it wasn't the same, and we needed to pull it out. And so we originally had it in that particular field.
Okay.
Well, good, Jim. The last question really could cap us off really well. I think they're just curious how to obtain the report. Is it going to be available on your website?
Yes, it will be on our website, and we will make, and we'll be going through you as well as an announcement as we near publication, and so that we'll make it available where they can get it probably directly online if I have it my way. So it's an electronic version and not a hard copy, although I'm sure we'll have hard copies.
Terrific. Yeah, we'd love to be able to. We can write a press release about it, make sure everyone that, you know, the webinar attendees will let them know, and they can just go to your site and download it for sure.
Well, I'm really excited because every day that I work on it, I learn something new, and something that was staring me right in the face, hadn't realized, and so it's. I hope that is the same thing that the readers of it will find as well, and help them on their crane planning and crane use.
Yeah, no, I think it will, and I really look forward to its development because I think it could be like a institution or a staple in the industry. You know, the Haag Crane Report, as you guys continually add to it year after year, right? I mean, that's that's the idea.
Yeah, and we're in fact we've had requests from several people, and it's. Probably another week it's going to be too late. I will say this, if some of the attendees have some issues they'd like addressed, if they'll send it either to you and you forward it to me, I can still get that included some way, somehow, or let you know it already is included, because the more input I have, the better off it is. And sometimes questions, once again, that you're not thinking about looking at, someone in a particular industry, it's a concern of theirs, and they'd like to have some answers. So I'm going to be getting after separating and segregating all the types of accidents. We're going to start right after Christmas doing the physical analysis of each and every single crane accident. And so if there's a particular item, we'll just add it into that list of something to look for.
Terrific. Well, that'll be great. I'll even chat with you offline here about how to set up it'd be good to have a discussion board or something that people can post to for questions. But there you have it, everybody. You can email me if you have any thoughts, and Jim will be able to modify and look. I mean, they spent a lot of time and energy in this, and we really appreciate you presenting on it, Jim. But it's just awesome. I think this will be just an industry staple for several years to come, so I'm excited about it.
Well, we certainly hope. We have our own crane group. We have 6 people that do nothing but crane accidents, and with all areas of expertise. As I told you earlier, we have 2 wind tunnels. We're doing 3 analysis wind flow tests on tower cranes right now. Of course, obviously one in New York, one at Rebel Tower in New Jersey, and then we have another one in Chicago. And because the wind flow tunnel we have here in Houston will do about 60 miles an hour, just to see how wind travels over and around objects in the crane. And then the one in Dallas, we can get up to about 200 miles an hour, which we're dealing there with some separate issues. They're still crane and rigging, but a little bit different. And sure. But also I want to say that once this comes out, we are always open for suggestions, recommendations, because we want to be as clean as we can, and we want to try to help the industry as best we can.
Sure. Well, that's terrific. We thank you for producing it. It's really an awesome thing you guys did, and thank you again for presenting here, Jim. We really appreciate it.
Well, my pleasure.
Okay. Well, thank you, everybody. Again, the presentation, the file will be available, and the recording for future viewing. Hope you had a great day and have a great rest of your week. Thank you.
Thank you.